Hey guys, this is Mrs. Lyons, and here we are in this video. We are going to go over combustion reactions, okay? And I am going to show you how to predict the products and how to balance, okay? So, to get started, and this is something that these should be equations you do not miss, okay? Because you identify it as a combustion reaction because it has this hydrocarbon, a compound that contains carbon and hydrogen. Sometimes it might have oxygen in it, okay? That's okay. And it's always going to be reacted with O2, okay? The nice thing about these, our products are always carbon dioxide gas and water vapor. So every single combustion reaction that you see is going to have the same products, carbon dioxide gas and water vapor. Carbon dioxide gas and water vapor. Carbon dioxide gas. And I did this many, and I'm predicting products first because I want to make the point. Okay? Never. You don't have to think about it. Don't look at it and say, oh, wait, what? How am I going to combine those? Wait, I've got 2 carbon and 6 and oxygen. Don't do it. Look at this. See, oh, look, it's a hydrocarbon. It's oxygen. My products are carbon dioxide gas and water vapor. Look, it's a hydrocarbon and oxygen. My products are carbon dioxide gas and water vapor. Ooh, this one's weird. It's got an oxygen in it, but you know what? It's still carbon hydrogen. It's still a hydrocarbon, still reacting with oxygen. Definitely not a synthesis, definitely not a decomposition. So our products are going to be CO2 gas and H2O water vapor. Okay, so I know I did that. I got annoying because I just kept saying the same thing, but I wanted to make the point. Products are always the same. Okay, now balancing these, and I'm gonna show you 2 ways that we can balance. These are hard to balance using the modeling method, but I'm going to do that with this first one, okay? But I'd like for you to, that we're going to do the rest of them using the tally method, okay? And the reason for this is some of these get really big and they have a lot of, there's a big coefficient, so you'd have to write down a lot to get it done, okay? But we're gonna try this using the tally method right now, or not the tally method, the modeling method. Okay, so here I have C2H6, so that's going to be C2, so 2 carbon, 1, 2, 3, 4, 5, 6. See why that's going to be a pain? Okay, so that's C2H6 plus O2, okay? And my product is going to be CO2, so COO, plus H2O, so HHO. Okay, so let's start with carbon. I have 2 carbon here. Over here, I only have 1, so I'm going to write COO. Okay, so now I've got 2 carbon on each side. I have 1, 2, 3, 4, 5, 6 hydrogen. Okay, which means I've got 2 here. So if I add another water, now I have 1, 2, 3, 4. If I add another water, I have 6. Okay. So let's see. I have 1, 2, 3, 4, 5, 6, 7 oxygen. That's a problem. All right. Because no matter how many oxygens I put here, I can't get 7. okay? Because I can't do this. I can't just add one oxygen. I have to add the whole O2, okay? Now, this kind of problem happens, okay, when you have an odd number of water molecules. Okay, see here, when I've done balancing my carbon and my hydrogen, okay, I only have 8 oxygen left. I've got 1, 2, 3 water molecules. Okay, here's what I want you to do. I want you to double your water and then go from there. Okay, so I've got 3 water. I'm going to add 3 more. Okay, so now let's go back. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen. Over here, I have 1, 2, 3, 4, 5, 6 hydrogen. So I need another one of these. Okay, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen on each side. I have how many carbon? 1, 2, 3, 4. So I've only got 2 here, so I need to add carbon, oxygen, oxygen, carbon, oxygen, oxygen. Now my carbons and my hydrogens are balanced. Let's count up the oxygens. I have 1, 2, 3, 4, 5, 6, 7, 8 here. And then I have 1, 2, 3, 4, 5, 6 here. So that's a total of 14 oxygens. So I've got 2, 4, 6, 8, 10, 12, 14. Okay, so now, finally, I have my equation balanced. So it took me 2 C2H6s, 1, 2, 3, 4, 5, 6, 7 O2s, 1, 2, 3, 4 CO2s, and 1, 2, 3, 4, 5, 6 H2Os. Okay, and this is why this method is not the best for combustion, because you take a whole sheet of paper to balance an equation. Okay, so I'm going to show you the rest of these using what I call the tally method. Okay, so here we have C3H8, all right, and we've got O. So I'm going to count carbon, hydrogen, oxygen. And I used to always say count carbon first, but you know what? So we're going to count them first, but then we're going to balance hydrogen first, okay? Just because we might get to that same situation. So C3H8. So I have 3 carbon on the left side of my equation. I have 8 hydrogen, and I have 2 oxygen, all right? On the right side of my equation, it's always going to be the same. I have 1 carbon, 2 hydrogen, and 3 oxygen. 2 oxygen here, 1 oxygen in my water. Okay, now I want to do hydrogen first, because that way if we end up with an odd number of water, we can double things right away. And this example is not going to get that for us. We'll get there though, I promise. So here I have 8 hydrogen. Here I have 2. So I have to come up with what can I use here as a coefficient that will give me 8. So what times 2 is 8? 4, right? So now I have 8 hydrogen. Okay, we'll go tally our oxygen once we get the hydrogen and carbon done. Okay, here I have 3 carbon. Over here I only have 1, but a coefficient of 3 here gives me 3 carbon. So now my carbon's balanced. So now let's add up our oxygen. So in carbon dioxide, I have 3 times 2. That's 6 oxygen. And in my water, I have 4 times 1. So that's 4 oxygen. So I've got 10 oxygen altogether. So what number do I have to put in front of O2 to give me 10 oxygen? Hopefully you said 5. 5 times 2 is 10. And our equation is balanced. Okay, so this just is a lot easier than writing this all down using the modeling method. So I would try to practice those so that you don't have to do all of that writing, because you have a limited amount of time on your test or quiz, and you don't want to spend all of it drawing pictures if you don't have to. Okay. All right. So here we go. Here's the next one. So we have carbon, hydrogen, oxygen. I have 6 carbon, 7 hydrogen, and 2 oxygen. On this side, I have what I always have, 1, 2, 3. All right. Now remember, I don't have 7 hydrogen. What was I thinking? I have 14 hydrogen. I was getting ahead of myself. 14 hydrogen. Sorry, guys. So like I said, I want to balance hydrogen first. Okay. So if I've got 14 hydrogen over here, what coefficient would I need in front of water to give me 14? 7, right? So see, this is one of those examples where we get an odd number of water. And that doesn't work because we can't have an odd number of oxygen. So instead of a 7, this is where the 7 was. I'm going to double that. So I'm going to put a 14 there. Okay? So 14 times 2 is 28. Okay? That's 28 hydrogen. So over here, in order to get 28, I have got to do 2 times 14. So now I have 28. All right. So now let's balance my carbon. So I have 2 times 6 is 12 carbon here, which means I need 12 CO2s. That gives me 12 carbon. So my carbon and my hydrogen are both balanced. Now we've got to do the oxygen. So 12 times 2 is 24. And then 14 from the oxygen. So if I add that up, I get 38. Math. 38 divided by 2. Oh, I better put here that I've got 38 oxygen. 38 divided by 2 is 19. Is that right? So 19 times 2 gives me 38. Okay, and this is why, can you imagine if you were balancing this using that other method? You'd have to write 19 O2s, 12 CO2s, and 14 H2Os. It gets really, really, really long. Okay, so I'd really like it if you would practice these and be able to balance them without having to write it all out. All right, here we go. We're going to do another one. Carbon, hydrogen, oxygen. I have 8 carbon, 18 hydrogen, 2 oxygen. Over here, guess what? 1, 2, 3. All right, so I'm going to look at my hydrogen first, because here I have 18 hydrogen. So what would I have to multiply by 2 to get 18? Guess what? An odd number. I would have to do 9. So I'm just going to double it. That's just something you got to get into the routine of doing. So I'm going to write down 18 water. So 18 times 2 is 36. All right. Over here, I'm going to need to put a 2 because 2 times 18 is 36. So now my hydrogen is balanced. 2 times 8 is 16. So over here, I need 16 carbon dioxide. Okay. So let's add up my oxygen. 16 times 2 is 32, right? And then we have 18 oxygen here for a total of 50 oxygen. I guess, yeah, there you go. So what is half of 50? 50 divided by 2 is 25. So 25 times 2 is 50 oxygen. Okay. So I really think as you balance these and as you practice, you will get better at it and you'll get faster at it. That's why I gave you so many of these. Okay. Here we go. Carbon, hydrogen, oxygen. I have 2 carbon, 2 hydrogen, 2 oxygen. On this side, I have, guess what? 1, 2, 3. This one might not be a bad one to do the modeling because it's littler numbers. Okay, so let's start here. 2 hydrogen. Oh, my hydrogen is already balanced, but you know what? With a 1 there, that's an odd number. So I'm going to double this. Okay, so 2 times 2 is 4. So to get 4 hydrogen over here, I'm going to have to put 2 times 2 is 4. And then carbon, 2 times 2 is 4. So that means I need a 4 in front of the CO2, which gives me 4 carbons. Then I have 4 times 2 is 8 oxygen, plus 2 oxygen is 10, which means I need a 5 there. Okay, so some of these aren't terrible. Some of them are. Well, they're not terrible. They're just, you just end up with big numbers. All right, C2H4 plus O2. So I have 2 carbon, 4 hydrogen, 2 oxygen. Here I have 1, 2, 3. Ah, thank goodness. Look, I have 4 hydrogen. So if I put a 2 here, it's an even number. I don't have to double. So now I have 4 hydrogen on that side. Over here I have 2 carbon. So I'm going to put a 2 in front of CO2, and that'll give me 2 carbon. Okay. Now I have oxygen. So I've got 2 times 2. I've got 4 oxygen plus 2 oxygen is 6. So a 3 right there. Ah, that was nice and easy. All right. It's nice when you have some shorter ones. Oh, but that only lasted for a minute. Okay. C2H6. So let's do this. CHO. So I've got 2 carbon, 6 hydrogen, 2 oxygen. On the other side, I've got 1 carbon, 2 hydrogen, 3 oxygen. So here we go again. If I need 6 hydrogen, that would mean I need to put a 3 in front of the water. 3 is an odd number, so I have to double it. So 6. All right, so 6 times 2 is 12. So to get 12 hydrogen over here, I would have to do 2 times 6 is 12. All right. Carbon, 2 times 2 is 4, which means I need a 4 in front of CO2. And then here I've got 4 times 2 is 8, plus 6 is 14 oxygen, which means I need a 7 there. Okay. 2 more. C, H, O. I have 1 carbon, 4 hydrogen, 2 oxygen. 1, 2, 3. All right. Carbon's balanced. Sweet. Here I have 4 hydrogen. Over here I only have 2. Guess what? I can put a 2 there, and that is a 4. So my hydrogen doesn't have to be, my water doesn't have to be doubled. Look at that. My carbon and my hydrogen are already doubled. So let's count. I've got 2 plus 2. I've got 4 oxygen. So if I put a 2 here, my equation is balanced. That was pretty. All right. Oh, and I guess I didn't put the 1s there. I wouldn't count it wrong if you leave those blank, but I would like you to put them there just so that I know that you thought about it. All right, this one's a little weird because we've got this weird way of writing it, and that doesn't really matter. We count it all the same, but what we have to think about it, we got to make sure we remember that that other oxygen is over there. So here I've got 2 carbon, 5, 6 hydrogen, and then I've got 3 oxygen because I've got 1 oxygen here and then 2 in my O2. Over here I've got 1, 2, 3. So let's see. So this, when you've got oxygen in your hydrocarbon, that rule about doubling doesn't necessarily play a factor. So we're just going to kind of go through this without thinking about the doubling for a minute. Okay. So I've got 2 carbon on the left side. To get 2 on the right side, I would put a 2. All right. I have 6 hydrogen on the left. So I'm going to put a 3 here. And let's see what happens. Okay. That gives me 6 hydrogen. Now, I have 2 times 2 is 4 oxygen plus 3 oxygen. So I've got 7 oxygen over here. Okay. Now, here's the reason we don't have to double it. Because I'm going to take 7, I'm going to take this oxygen, so 7 minus that one is 6. So I need 6 oxygen more, which means if I put a 3 there, 3 times 2 is 6, plus 1 is 7, and that's balanced. Okay? I hope practicing all of those combustion reactions helped. If you want to challenge yourself, this is an insane problem. C25H52. Good Lord. I am just going to leave that out there. And if you want to balance it and you can do it, I would love to see it. All right. And we're just going to skip this one just because I'm not going to give you any word equations to write. You'll just see combustion in the predicting products and balancing. Okay. But if you can do that, I probably have candy for you. All right. Have a great day. I will see you in class. Take care of yourself.